Good morning. Today we will continue tutorial chapter 2 part 2 from question 8b. So the two condition we need to verify is, first condition is we need to verify the fx is greater or equal to 0. The second condition is the summation, if you integrate fx you should get 1. Okay, these are the two conditions we have to check. For b, you can see that gx is 2x. So clearly if you put any value here, okay, any value inside 2x, whereby the x takes 0 to 2, the gx is always greater than equal to 0. Okay, this is first condition fulfilled. Second condition, let us find 0 to 2 gx you will get 4, which is not equal to 1. Therefore second condition is out. Therefore gx is not a probability density function. That is regarding B. Now C. First condition is, if we have to see whether hx is greater than 0 or equal to 0. If you put x, you see, we have to make sure this function is always greater or equal to 0. So your x is in between 0 to 2. If you replace x equal to 0 inside the function, you get negative 3 over 2, which is less than 0. So first condition is out. Okay, it is not always greater or equal to 0. So first condition is out. Therefore hx is not a probability density function. D, if you replace any value inside here, okay, x in between 0 to 1, you replace inside this function, it is always greater or equal to 0. You can try. Okay, you try put 1, the maximum number there. Maximum number is 1. You replace inside here, you can still have 1 over 2, which is greater than 0. The first condition is okay. Second condition, For the second condition, you have to integrate this. Then if you integrate, you will get 3 over 2 minus 1 over 2 equal to 1. So this is equal to 1. This is also fulfilled. Therefore, kx is a probability density function. Yeah. In the previous class, I already told you this is not the condition. The condition, first condition, is greater or equal to 0. We are moving to question 9 now. Find the value of question 9. Find the value of constant k and find the probability 2 to 8. So the constant k as I told you before, in continuous random variable, you replace this 5 inside here and the value of 5 inside here. Both value should be same. So that is the idea. So here 1 over 10 5 must be equal to solve this. 1 over 2 is 25 k plus 1 . So if you solve this, so k is negative 1 over 50. And if you want to find the probability 2 to 8, that would be integrate 2 to 8 the function. So in this case you don't need to integrate because they have given you the cumulative distribution function. If they give you density function, then you integrate. Now since they already give you the cumulative function, what we do, the what you call these intervals are from 0, 5, 10. We want from 2 to 5. So 2 is here, 2 to 8, and 8 is here. So we want 2 to 8. What we will do, we will find from 8. Here you will get f8 only for cumulative distribution function. Cumulative distribution function, we will do that f8 minus f2. Here this is f2 minus f2, you will get the green color. So 8 falls in this interval, so we have to take this function. We already found k is negative 1 over 5, 1 over 50 something. So replace k negative 1 over 50. Our x is 8 minus 10 square plus 1 minus 2 falls inside this interval, so we have to take this function 2 over 10. If you do this, you can try do this, your answer should be 18 over 25. Find the probability density function. So for us to find B is find the probability density function. Yeah, for us to find right here B, from density function to cumulative function we differentiate, sorry, if we integrate from cumulative to density we differentiate, the reverse process we can do immediately. So this 0 you this 0 you differentiate because we want density function. If you differentiate 0, so no need to write that. Now this one you differentiate, you will get 1 over 10 for the interval 5. Done. Remember this k is negative 1 over 50. Remember that. So when you want to differentiate this one gone, left is negative 1 over 50. So let me do here. When you differentiate, let's say y is negative 1 over 50. So you want to differentiate, you want to find dy dx. This is what you do. So your answer is negative 2 50. Just give me a time, I need to double check. Yeah, this is the answer. Negative 2 over 50 I think in the answer I left the negative. This is question what? Question 9. Question 9B. Yeah, here there should be a negative here. Okay, this one, take note that there should be a negative. This one we can write 1 over 25, no problem. 10 minus x, is it? And question is oh, okay. No, it's not a mistake. It's just I take out the negative outside there. Sorry, this is also acceptable. This answer is acceptable. This answer also acceptable. You see the position here. If you write 10 in front minus x, then there's no negative. Here x minus 10, then there's a negative. You can leave the answer like this, the one I write here. Okay. If you can get the one here also, no problem. Both are okay. Both are acceptable. Now this one is 0 otherwise. So this is the answer for B. Find Ex give your answer in 3 decimal places. Okay, let us find the expected value, variance, blah blah blah. Expected value, I am going to use the density function. Can take out negative 1 over 25. You should get 4.583. This is your expected value. Expected value of root of x, same manner you can find. If you do this, you can try this, the integration anyway. So if you complete this, you substitute all the values, you should get this one. Okay, you try do this. So we want variance of this is actually expected value minus this one. So this is x and this is still remain same. If you do this, Ex is just now 4.83 minus 2.031. This is the answer. Question 10. This is continuous random variable probability density function. If the mean of x is 2.25, find the a and b. They say the mean of x is 2.25, find the, so the clue is the mean. Mean is 2.25. 1 to 2 ax dx plus 2 to 4 bx dx equal to 2.25. This is equation 1. I just want to get some nice number, that's why I times by 2. I don't want decimals. This is one clue. Another clue is the summation is 1. Sum of probability is equal to 1. So you integrate 1 to 2. This time don't multiply with x. This is the second equation. So we take 1 and 2, try to solve it. Instead of putting this as second equation, my first equation, I have this. Which one I can eliminate? Okay, let's say I want to eliminate a, so I multiply by 6. So 6a. 6. This is my second equation. So 3 minus 2, you will get 12b. 3b is equal to 1/4. Therefore you substitute in any equation, you should get a equal to 1/2. Okay, this a you can substitute in any equation. This one also can, this one also can, anything can. So you get your function. Okay, this one is a is 1/2, b is 1/4. B. Determine the value, expected value for 1/x. This one I think you can do. Okay, so 1/x, then you multiply each function by 1/x. 1 2 1/x, supposed to be a, but our a is 1/2. 2 to 4 1/4, and our b is, sorry, this is 1/x, our b is 1/4. So if you do this, this is the idea. If you do this, I suppose you guys can do now, multiply, integrate. For this integration, maybe I can help you. Let me help you here, because it involves ln. Most of you, I think most of you forgot how to integrate this. Just recall back. 1/x, if you integrate, you will get ln x. You forgot about this. In maths, we've been gone through this. So this one is ln 2 plus 1/4. Okay, let me do one by one, in case if you guys want to have detailed manner. So ln 1 is 0, so left is 1/2 ln 2. this one ln minus what we can write this, how we can write this, we can write it become like this. This is actually ln 2, so ln 2. If you do this, then you will get 3 over 4. Simple algebraic computation. This is the answer. See, find the value of k (0.375). Okay, so this one we need to find from the lowest k is 1. Lowest value of x is 1 because start from 1 here. Okay, so 1 to k fx dx is 0.37. Now we have done this before. The explanation goes like this. Now first of all, there are two intervals, 1 to 2, 2 to 4. K can be here, k can be here. Okay, we don't know where is k now. Okay, but then the total probability until k is 0.375. Now if we want to let us find this probability 1 to 2. Okay, let us find this. We do it here. 1 to 2. And what is the function for the thing is 1 over 2 and dx. If I do this, and I will get 0.5, 1 over 2. You see, this from here to here total, if I integrate from here to here, the total probability is 0.5, but this one is 0.375, which is less than 0.5. Therefore k must be in here, inside this interval. If this one, let's say this is let's say this is 7, then if 775 is more than 5, more means it goes into this interval, so k must be here. Okay, that's the idea. But then the question tells it is now 375. 375 is in between, less than 0.5, so k must be somewhere here. Okay, identify where is the k. K must be somewhere here. So the function only involved, the function involved is only the function related to the interval 1 to 2. Okay, so the function would be 1 over 2 K is 1.75. That is K. Question 11. A continuous random variable x has a probability density function. Given that, find the value of constant k. Okay, for question 11 we skip it, we don't do question 11. Okay, don't do, we skip this. There's some I need to rectify certain things. Question 11 don't do, go for question 12. Oh. Question 11. Also you can skip, no need to do, skip for a while. Actually I need to add some more information inside here. Next time I will inform that. The mean variance you can find from the thing, expected value you can find from 13. 14, find the mean and random variable variance, you can find that. And 15, we will do 15. For those question 11 and 12, don't do, because I need to insert more information. I just noticed that. Never mind, you don't need to do. Question 15. We go for question 15. Petrol is delivered to a garage every Monday morning. At this garage, the weekly demand for petrol in thousands of liters is continuous and a variable. Probability density function is given there. Given that mean weekly demand is 600, determine the value of A and B. So I give you a clue here how to do. You guys can try. The first clue is the mean is 1 to 0, in liters. Thousands of liters. Okay, thousands of liters. So this one would be 0.6. Thousands of liters. This one will be 0.6. And the first clue is a mean. For a mean you have to multiply by x. This is 0.6. So if you solve this, okay, you do your computation. If you solve this, you will end up with one equation: 5ab minus 4a equal to 12. This is your first equation. Another clue is the summation of probability is 1. So 0 to 1, ax b minus x dx equal to 1. And if you do this, you will end up for another equation, which is 4ab minus 3a equal to 12. This is another equation. Do simultaneous equation, solve 1 and 2, and you will get your a is 12 and b is 1. Okay, try do that. Question B: if the storage tanks at this garage are filled to their total capacity of 900 liters every Monday morning, what is the probability that in any given week the garage will be unable to meet the demand? Unable to meet the demand, X is demand in demand of petrol, of course in thousands of liters. So this demand must be greater than 0.9. Demand must be greater than 0.9 because they said find the probability that in any given week the garage is unable to meet the demand. Unable to meet the demand means they are not enough petrol. Every Monday morning they have only 900 liters, which is 0.9 liters, because 1000 of liter, 0.9 liters. If unable to meet the demand, the demand, people asking more than 0.9, so that is a demand. If you do this, of course, how I get 12? Because A is 12. And B is 1. So you replace again the thing. You get this one. And your answer should be 0.0523. So that's all regarding this tutorial, chapter 2, continuous. Forgive me for too many typos and adjustment. Then try to rectify all these things. So I will see you in the next tutorial. With that, take care and bye bye.